Iceland is known for volcanoes. In early March of 2021, small earthquakes began increasing in the southwestern part of Iceland. These earthquakes were telltale signs that a volcanic eruption was imminent. By mid-March, volcanic flows began, and the government asked residents to please stay away. But after the lava flow subsided a bit in intensity, the locals just couldn't resist. After all, this is Iceland, and folks are used to volcanoes. In news footage, it looked like a musical festival, except with lava flows in place of where the band should be. People everywhere, lots of happy faces, personal camera drones up in the air taking pictures. There was even a group that brought condiments and used the recently crystallized lava to cook pilsar, a world-famous Icelandic sausage. So was visiting those lava flows dangerous? Crazy? Or maybe both? It turns out you too, if you take proper precautions, can safely visit a lava flow. And very frequently, they do put a smile on your face. This lecture is about volcanic landscapes, specifically different types of volcanoes and different types of volcanic rocks. We'll also talk about volcanoes that you can visit, how to explore volcanic terrains, and what to look for. These observations will enable you to understand the volcanic eruptions that have taken place and the history of these eruptions. Several years ago, the University of Minnesota Morris Geology Department went to the Hawaiian Islands to observe the volcanic activity and volcanoes that exist on the Big Island of Hawaii. Hawaii is a geologic paradise. While we were there, we made arrangements with a park ranger to guide us to the southeastern edge of the island where a lava flow was entering the ocean. This park ranger had a lot of experience and had been to this location a number of times. Normally, we would have stayed behind barricades that the Park Service routinely sets up. But with a guide, we were able to walk across the recently crystallized lava flow, essentially new rock. And you could feel the lava still flowing in lava tubes underneath what was a relatively thin crust. When we got to where the lava was flowing into the ocean, the experience is hard to describe. All of your senses are caught up in the geologic process of making brand new rock. The lava was flowing into the ocean, and the rapid quenching and crystallization resulted in the release of sulfur-rich gases that produce a smell that is common in volcanic terrains. The sounds of water instantly turning to steam as the lava touched it. Lava moving through the nearby lava tube shook the ground in a constant rumble. And of course, there was heat. It was hard to stand on the hot rocks, even if you had really good boots. And when you tried to sit down, a heated butt necessitated standing again. But it was an amazing experience and an opportunity to see volcanism in action. Now, we had an experienced guide, and that's what made it relatively safe. Elsewhere, all along the trail, we could see windows in the rock crust and the lava moving below. But with a guide to keep you safe, walking on newly formed lava is an experience you will never forget. Volcanism is the process by which new rock is made from a liquid. At depth, that liquid is called magma. On the land surface, that liquid is called lava. And the process of turning that liquid into rock is called crystallization. Depending on the nature of the magma, the geologic setting, and the mechanism of volcano formation, different types of volcanoes form. The three most common types of volcanoes are shield volcanoes, cinder cones, and stratovolcanoes. Which kind of volcano you get depends on which kind of lava is flowing. The Big Island of Hawaii is a shield volcano. Shield volcanoes are made up of an accumulation of lava flows. They have a broad dome shape. The name shield volcano arose because people thought they looked like a warrior's shield. Most shield volcanoes develop on the ocean floor and are made up of basaltic lava flows. Basalt is the principal rock type of the ocean crust. In addition to Hawaii, the Canary Islands, Iceland, and the Galapagos Islands are examples of shield volcanoes. Occasionally, shield volcanoes form on continental crust. One example is the Newberry volcano in Oregon, a seismically active volcano that last erupted 1,300 years ago. But for locations like Hawaii, the question you might be asking, and certainly the question I got asked when I returned from Hawaii, was, isn't going that close to a lava flow dangerous? It is a very legitimate question. Volcanoes can, in fact, be very dangerous. On the other hand, with a well-informed guide like the park ranger that was with us, it was a relatively safe experience. Moreover, shield volcanoes in particular are considered to be relatively safe. First, eruptions from this kind of volcano can usually be anticipated. The summit of the volcano tends to begin inflating and rising months before an eruption. Second, the lava flows from this kind of eruption stack one upon another and flow quickly and smoothly, like rivers of lava. Third, this rapid discharge of a very fluid material means that crystallizing rock material does not build up or clog up the volcano. That means that gases can escape easily. Volcanoes become more dangerous when either volcanic gases or magma trying to get to the surface become trapped by crystallized rock above. In such a volcano, pressure builds and can become explosive. That rarely happens in shield volcanoes. That's why island volcanism, such as you find on Hawaii or Iceland, is relatively safe to visit. In fact, if you're thinking about seeing a volcanic terrain, I can't imagine a better place than Hawaii. One of the reasons that Hawaii is such a great place to observe volcanic rocks is because it's very young. The now active volcano on the Big Island has erupted a number of times in the recent past, including 1950, 1953, 1959, 1960, 2018, plus an especially big one way back in 1790. That means that the rocks haven't been subject to weathering and erosion. In many cases, it's as if they just formed. The park surrounding the erupting portions of the volcano has numerous trails that will take you over older lava fields. Additionally, the roads throughout the Big Island are cut in volcanic rocks, making it so you can simply park your car in a designated parking area and explore the volcanic terrain nearby. Moreover, much of the Big Island is federally owned, so you can have access to a very large area. But nonetheless, you do have to be sure of where you are. Private property owners can be fairly aggressive with trespassers. Fieldwork in volcanic terrain requires extra care and brings some additional safety considerations. Small children and people with respiratory issues especially need to avoid prolonged exposure to volcanic emissions and volcanic ash, which are hazardous to health. Even for locations where active volcanism has ended, you also have to take care that you're not stepping on an inactive lava tube. If the tube is a thin roof, it can collapse. Never reach into a lava tube or a small cave. You can disturb the wildlife, and certainly don't try any technical climbing. The most common problem doing fieldwork in Hawaii is heat. This kind of black basaltic rock absorbs sunlight and heats up. It is used in solar heating systems. So in addition to the warm air temperatures, late in the afternoon, the rock will be radiating heat. Good shoes and lots of water are important. It's also best to stay away from coastal exposures. Volcanic fieldwork and ocean waves can be a dangerous mix. But with these precautions and proper preparation, exploring the volcanic terrain of Hawaii can be incredibly exciting. Remember, unless you have received permission from the Park Service, collecting is prohibited. You're there just to look, not sample. When you start off doing fieldwork in volcanic terrain, there are actually two types of material to look for. The first is pyroclastic debris, from the word pyro, meaning fire, and the word clast, meaning rock. This debris crystallizes as an individual rock from lava that is blasted into the air. This is an example of scoria, where rapid crystallization has resulted in the entrapment of gas bubbles. Some volcanics are quenched so quickly that they take on the appearance of glass and become obsidian. One of the ways obsidian forms is by rapid quenching while lava is airborne. Other pyroclastic rocks, like this volcanic bomb, still have liquid in them as they are ejected out of the volcano. While flying through the air, they have the capability of deforming and frequently develop a streamlined form because they're still part liquid. The largest of these particles, and they can be up to 1 meter in diameter, are called blocks, and usually blocks don't have a very streamlined form. But with smaller sized particles, which are called bombs, the particles tend to develop a streamlined shape. Even smaller examples have the size and shape of an almond and are called lapilli. Lapilli is the Italian word for little stones, about the size of an almond. Bombs and lapilli are pointed on either end and streamlined. Again, this is the result of being part liquid as they fly through the air. When pyroclastic debris is even smaller, it's called ash. Ash is a common product of volcanic eruptions, and it is capable of being suspended in the atmosphere for long periods of time. Ben Franklin was the first scientist to recognize that volcanic ash in the atmosphere can alter the amount of sunlight reaching the Earth's surface and cooling the climate. There are also more fragile types of pyroclastic debris to be found in Hawaii, if you have good luck. These types are really very fragile and are destroyed relatively quickly. But if you have a good eye, it can be worth the effort to look. The first is called Pele's Tears. Pele, of course, is the Hawaiian goddess of volcanoes. As I mentioned, if lava is ejected from a volcano, it can quench quickly and take on the properties of glass. In fact, it's called volcanic glass. But in the case of Pele's Tears, not only has the lava quenched quickly enough to be glassy and translucent, it also solidifies in a streamlined form. The result is a clear, teardrop-shaped rock that indigenous people of Hawaii called the tears of an unhappy goddess. Another type of pyroclastic debris associated with indigenous legends is Pele's hair. Pele's hair is made up of strands of volcanic glass that are thin enough to be mistaken for hair. How does this happen? I find it helpful to compare Pele's hair to cotton candy. When I was a kid one Christmas, I got a cotton candy machine. This turned out to be a terrible present because I made and then ate a half a pound of sugar that morning. And of course, I was a joy for my parents to try and settle down. But that cotton candy machine taught me how Pele's hair is made. You put a spoonful of sugar in a container that is in contact with a heating element in the center of the cotton candy machine. The container has holes in it, so the melted sugar leaks out in small drops. What generates the cotton candy is the rapid rotation of melted sugar. With pressure from the spinning motion, the liquid sugar is forced out of the holes and it crystallizes as soon as it comes in contact with the air. The magic happens as the acceleration elongates the droplets into stretchy fibers that resemble strands of cotton. That same process can happen in volcanoes. As pressure ejects lava rapidly out of a volcano, droplets of rapidly crystallizing liquid are stretched and elongated, taking on the characteristics of hair. Of course, Pele's hair is still a rock, so you have to be careful when you lift them up, or they can form a splinter. Remember, you have to choose your field area carefully. Pele's hair is not frequently preserved in older volcanic terrains. But when you do find Pele's hair, you know immediately what it is because it does in fact look like blonde hair. Another thing to look for in volcanic terrains, in addition to pyroclastic debris, is flow features. As lava flows and crystallizes into rock, the rock that forms preserves a record of the way the lava was flowing. In Hawaii, the lava has very little silica, and as a result, it flows quickly in most cases. Very rapidly moving lava will form what is known as entrail lava. It's a very descriptive term. The way it forms resembles the way icing will flow if you put it on a cake that is too hot. Icing on hot cake almost becomes a glaze in places where this type of lava flow piles up. Say at the bottom of a hill, the flowing lobes really do look like entrails. This ropey lava is more common and called pahoehoe lava. Pahoehoe lava is as if a very loose rug was being folded over itself into small folds and still flows pretty quickly. A more sharp and blocky lava is called a'ā. The slowest of the three main types of lava flow is the a'ā lava. That slow flow is why the surface crust of the lava ends up breaking into sharp chunks. When trying to remember which is which, you can remember that walking on the sharp pieces of a'ā would make you say, ah, ah. The word is almost like onomatopoeia for the reaction people have trying to walk on it. Actually, both a'ā and pahoehoe lava can form within the same flow. The difference is due to gas content that can change quickly. It's not that common, but some lava flows will have both types of flow features in different parts of the flow. Entrail lava, pahoehoe lava, and a'ā type lava all can be found easily in Hawaii. And because these features form in a fairly resistant rock type, these three types of lava flow features can also be found preserved in much older volcanic terrains, where volcanoes themselves are no longer active. To my amazement, there's an outcrop of pahoehoe lava exposed along the north shore of Lake Superior. These north shore volcanic rocks formed over 1 billion years ago, but the flow features look as fresh as the very recently formed pahoehoe in Hawaii. There are many other places where you can visit well-preserved volcanic features, even where volcanoes are no longer active. In the late 1960s, NASA started bringing astronauts to Idaho's Craters of the Moon National Monument to train for the lunar missions. And that training program continues in preparation for work on Mars. The astronauts work in regular field clothes, not dressed in moon suits. And the only equipment they carry are rock hammers. They go there to learn what to look for and sample on volcanic terrain formed billions of years ago on the moon and on Mars. Those landscapes, seen through grainy black and white images, can seem otherworldly. But in reality, old lava flows on Earth sometimes have a good deal in common with the long-ceased lava flows found on our neighboring rock worlds elsewhere in the solar system. At Craters of the Moon, there is an incredible concentration of volcanic features, including cinder cones, lava flows, pyroclastic and flow features, and lava tubes, the pathways for lava to flow that are now caves. It is a great place to visit. Let's get back to our discussion of types of volcanoes. A second type of volcano is a cinder cone. Cinder cones are made up almost entirely of pyroclastic debris. The pyroclastic particles that make up cinder cones can be very small, smaller than a centimeter in diameter, or they can be much larger. The one distinguishing characteristic of cinder cone pyroclastic debris is the presence of vesicles. This is a sample of vesicular basalt. Vesicles form from gas bubbles getting trapped in the lava as it crystallizes. So during the formation of a cinder cone, you literally have rocks piling up in layers in a classic volcano cone shape. Cinder cones frequently form very quickly. Studies have suggested that half of all cinder cones form in less than a month, and 95% of all cinder cones form in less than 1 year. They're small, between 30 and 300 meters tall, and have steep slopes between 30 and 40 degrees. Again, made up of pyroclastic debris. Cinder cones usually occur in groups. In general, are considered very safe, although they can have serious consequences. The growth of a cinder cone, Paricutan, in 1943, 320 kilometers west of Mexico City, was filmed from the initial release of gases in a cornfield to the formation of a 1,000-meter cinder cone in just 5 days. A little over a year later, the lava broke through the base of the cone and flooded nearby villages. This kind of late-stage lava flow is a common occurrence with cinder cones. Fortunately, people had abandoned the village by this point, but the buildings were totally overrun by the flows. Many cinder cones have formed on the flanks of Hawaiian shield volcanoes, but older cinder cones are visible even in places where volcanoes are no longer active. For example, there are over 600 cinder cones on volcanic terrain that's near Flagstaff, Arizona. The most accessible cinder cone is Sunset Crater, a national monument just north of Flagstaff. Sunset Crater was formed probably between 1080 and 1150 AD. It is 340 meters high, and there is a trail at its base. Sunset Crater is a typical cinder cone. It's made up of layer upon layer of loose pyroclastic debris. There once was a trail to the top, but the proliferation of hikers led to too much damage of the fragile walls of the cinder cone, so the National Park Service closed the trail. In fact, Sunset Crater had a history of overuse. In the 1920s, a Hollywood film company wanted to fill the crater with explosives and set them off to reenact a volcanic eruption. The public outcry led to the declaration of the volcano as a national monument in 1930. Along the trail around Sunset Crater, you will see the most recent lava flow, the Bonita Flow. This flow has begun to be revegetated, but along the trail you can still observe excellent examples of ash and lapilli, the almond-shaped pyroclastic debris. Although close to 1,000 years old, the Bonita lava flow is very well preserved and still looks very fresh. I can't leave behind the subject of cinder cones without mentioning an experience that isn't on my bucket list, but many people find exciting. In Nicaragua, tour guides can arrange a hike to the Cerro Negro cinder cone near the city of Leon. Once there, adventurous tourists participate in an activity known as volcano sliding or volcano surfing. Cerro Negro is the youngest volcano in Central America, and it has erupted over 23 times since it formed 160 years ago. Because of the friable nature of the fresh cinders that make up the cinder cone walls, you can slide down the cinder cone on a snowboard-sized plank. The guides will set you up with coveralls and goggles. I also would recommend bringing your own gloves and a helmet. You sit on the board and slide down for the volcanic adventure of a lifetime. Of course, if you do this, it's best to remain in an upright position during the sliding. Loose cinders are really abrasive. CNN named volcano sliding one of its top 50 fun but terrifying experiences. The last type of volcano is a composite volcano. It's also called a stratovolcano. These are perhaps the most beautiful or picturesque volcanoes in the world, but they're also very dangerous. Stratovolcanoes are the volcanoes that make up the ring of fire surrounding the Pacific Ocean. The reason stratovolcanoes are so picturesque is because they are large, very symmetrical mountains that are frequently covered by snow and glaciers. Stratovolcanoes form from alternating lava flows and layers of pyroclastic debris. Stratovolcanoes are usually characterized by magmas with high silica content. Although this isn't always the case, especially if the rock that the magma rises through is low in silica. High silica content usually results in a very viscous magma. When the volcano starts generating layers of viscous lava and pyroclastic debris, the result can be like a concrete. It gets very hard very quickly. When additional magma is being forced up from below, high pressures result. Very dangerous and very explosive eruptions can occur. Almost any stratovolcano you visit in the United States, say Mount Rainier, for instance, can be a marvelous experience. It is a beautiful mountain, but the scale of exploration is much greater than the other two types of volcanoes. It's hard to study the geology of an entire mountain. You certainly will find interesting rocks and features, but you have to prepare ahead of time. Learn about the area in advance. Use precautions that you would use in any mountainous environment, and get advice from rangers or guides. One interesting aspect of studying stratovolcanoes is applying modern observations to archaeology. For example, the Mount Vesuvius eruption in Italy nearly 2,000 years ago had several components similar to that of modern eruptions, but of course, much more catastrophic. Most believe that there were up to 6 directed blasts, essentially lateral explosions of tephra, which is ash and rock, that caused most of the damage. In the town of Herculaneum, to the east of Vesuvius, people were fleeing to the shore of the Bay of Naples and were engulfed in a cloud of pyroclastic debris that had internal temperatures in excess of 500 degrees Celsius. In Pompeii, further to the south, many of those able to survive the directed blasts were engulfed and perished in the subsequent ashfall, a steady fall of hot volcanic ash from the sky. The famous Garden of the Fugitives in Pompeii are casts of victims of that ashfall. Even further to the south was Stabiae. It seems that the residents of this resort town survived most of the directed blast, yet the buildup of ash on the hillsides that came cascading down as mud flows essentially led to the end of the city. All this is revealing information for archaeologists. The people of Herculaneum abandoned the city quickly, leaving all their belongings and individuals who could not travel in their homes. Even the buildings were heavily damaged by the force of the directed blast. The residents of Pompeii, who were engulfed in the ashfall, had time to grab their most precious objects, leaving those objects preserved within the tephra casts as a record of what was considered valuable at the time. In Stabiae, the mud flows appear to have caught residents by surprise. The remains preserved a record of their struggles to survive, while many structures were relatively unaffected. Systematic excavations of Pompeii and Herculaneum began in the 1700s. It has often been suggested that these volcanic excavations represent the beginning of modern archaeology. Excavations and discoveries continue to this day, with details of both the archaeological record and the record of the eruption becoming increasingly refined. One practical result that comes from catastrophic eruptions of stratovolcanoes is the creation of pumice. Pumice, of course, is an extremely lightweight, as well as typically light-colored igneous rock. Then there's ordinary rhyolite, the silica-rich rock associated with stratovolcanoes. Pumice has an abundance of trapped bubbles. Rhyolite does have some gas bubbles trapped in the rock as it cools, but pumice has more, and the result is a much lighter rock. This is why some pumice floats. There are stories of pumice islands found floating in the ocean, but these aren't solid rock features. They're more like a large collection of smaller classes of pumice floating together. They will break up if struck by a ship, and they will move up and down with waves. Eventually they become saturated and sink. Still, they're interesting to see from the air. Pumice is produced during explosive eruptions of silica-rich magmas, the viscous magmas commonly associated with stratovolcanoes. The rapid expulsion of magma in explosive volcanic events results in a rapid release of pressure and expansion of gases and rapid crystallization of rock. The explosive volcanism that produced Crater Lake in Oregon resulted in the deposition of large pumice deposits. About half of approximately 400,000 tons of pumice mined in the U.S. comes from Oregon and Nevada. What makes pumice so useful is it's a great abrasive, so it shows up in both beauty products and cleaning products. In ancient Egypt, it was used as an exfoliant and hair remover, and even made its way into an early version of toothpaste. I don't recommend that one. But there are many products that incorporate pumice today: soaps, exfoliation products, abrasives and polishes, and pencil erasers. Pumice is used in the manufacture of stonewash jeans and to filter liquids like olive oil. Pumice in consumer products may be its most familiar uses, but far more pumice is used in construction and landscaping. When crushed pumice is mixed in cement, most of the pores from the pumice remain in the mixture. The result is a cement hybrid that is lighter and yet also provides more insulation than regular cement. Pumice blocks are also used in construction for the same reasons, because they are light and provide insulation. Pumice is also used in landscaping. It's both lightweight and decorative. So keep your eyes open. Volcanic landscapes are worth visiting, and volcanic products can be found in interesting places.